So friends, in this video we are going to learn how the USB Type-C power delivery works. So first of all, we are going to understand the pinout of the Type-C connectors. So this is basically the connectors, and in this connector you can see that there are a number of pins. So first, this connector you can use like on the both the side, you can flip the connector, then also the connections or the pinout will be remain same. Okay, so when we are going to connect the Type-C connector or on our mobiles or our laptops, we can connect this connector on the any directions. Okay, so first of all we are going to learn, or we are going to see the pinout. So this last two pins are the ground. These are the ground connections. Okay, and this two for the RX means the received, and this two pins for the TX means the transmit. Here is a two transmit, two received. That means on the both directions, one is a transmit, received, transmit, received. This for the USB 3 purposes. Then these two connections, these two wires, V-bus stand for the voltages, that means the supply. Normally in our USB 2 ports, we can see there are 4 pins, 2 pins for the data lines and 1 pin for the ground and another pin for the supply, that is for 5 volt. In here in the USB Type-C port, this connection is called the V-bus. V-bus stand for the voltages, supplies. And this supplies is on the bidirectional. Bidirectional means like the data goes from the bidirectional, means that the data go inside also, comes out also. Similarly, the powers deliver on the both sides, so that it's mean. Okay, the next thing is this is D minus and D plus is a data line. The data for the USB 2, that means in this entire connectors have the USB 3 also and USB 2 also. And this two more connection, this is for the CC. CC stand for configuration channel, CC1 and CC2. CC for configuration channel. Configuration channel is basically a communication protocol between the two devices. That means when the two devices are connect with each other, they first talk with each other and accordingly they share the power, like that. Okay, so these are the pinout for the USB type connectors, USB Type-C connectors. Okay, this is our next slides, and in this slides we are going to learn how the power delivery take place between the USB Type-C port. Suppose so this is the adapter side. Okay, so this is my adapters. This entire string is my adapters. Okay, so this is my adapters. Now the adapter output is a 20 volt. Okay, adapter output is a 20 volt, and this adapter I am going to connect one laptop. Okay, but this adapter can't deliver directly 20 volt. So then how much voltage it can gives? So let's learn that. Okay, now this is my, suppose this is my laptop side. This is a source, V-bus is a source, and this is a sink. Source means where this power is going to delivered, and is a receiver. Okay, is a transmitter and is a receiver. Now when we connect the connection, suppose when we connect the Type-C connector to the laptop like this connection take place. V-bus is connected to the V-bus, CC bus is connected to the CC, CC1 connected to the CC1, or vice versa. Okay, if we flip the connector, then CC1 will connect to the CC, this CC1 connected to the CC, like that. It will the cross connection. This connection connected to here and this will connected to there, like that. The ground, of course the ground is required, that is the two last pin, and this is a positive voltage for it's called the V-bus. Okay, now the connection is established. Once the connection is established, then first it decides that who is a giver and who is a taker. And here this department is the connection detection and the power control. Connection detection is a power control. There's a two department. They first communicate with each other and they decide who is a giver and who is a taker. Suppose he is a giver and he is a taker, he is a receiver, then that CC connection will be ground, or it's a give the 0 volt. It's a connected to register to the ground, register to ground, and this CC connected to the 5 volt. That 5 volt, it's connected to the 5 volt means he is a sender, and connected to the ground means he is a receiver. So first it decide, okay, and once it decide, this he will send not 20 volt directly. This is the adapter. It's a same adapter like it's generator 20 volt, but here is a MOSFET that will control the output voltage. MOSFET not allowed to pass all the 20 volt that side. He control the 20 volt. So first he pass only the 5 volt. He pass only the 5 volt to this department. Okay, he just pass only the 5 volt from this V bus, and this 5 volt is going to the laptop. Once the laptop receive the 5 volt, he start communicating his devices, detection and control circuit that receive this 5 volt and check everything is if everything is normal. Then he ask higher voltage, because suppose he need a 20 volt or he need a 15 volt, whatever. So suppose he need a 20 volt, then what he do is he ask 20 volt from this line. I already told you this line for the communication purpose, CC1 and CC. Okay, so what he do is he just sending the data line to this port and asking the 20 volt. He received the 5 volt, but he needed 20 volt. Okay, so he send a data for I need a 20 volt from CC line. Once this detection circuit received this signal, then what he do is he trigger this MOSFET and pass a 20 volt. Okay, so he's pass a 20 volt, and in this way the receiver receive the 20 volt. In this way type C power delivery works. So this USB power delivery on the bidirectional. So in this way communication take place. So in this way we understood how the system works in this video. In next video we are going to learn how the buck boost converter works. Thank you very much.